Hey there. So today we'll be working on my_malloc function. So in the previous video, we made some changes to the traverse playlist function, which is this one, because we had to accommodate for like the new change, which is previously we had free list as a singly linked list, but now we will be having it as a doubly linked list, so as to have access to the previous block easily. So this is what the change was. You can like you can't see the change over here, but let's get started on my malloc function. So my first thought was like, should we get the align size aligned to 16 bytes? But I guess 8 is fine. Like if someone asks for 5 bytes, then it will automatically become 8 bytes, and then we will traverse the free list and try to find a block which is like let's say 8. So 8 would be the requested size, and then we will try to uh, this is current not equal to none, which is we traversing the sorry we this is we tra this is like traversing the free list and trying to find like so so 8 bytes and actual size. Let's say the smallest free list that we find is of like let's say uh, the smallest that we can find is of like 0 bytes, I guess. So let's say we find one with 0 bytes. So 0 plus pointer size is like 8, 8, and that's 16. Why do we have plus pointer size over here when we are like comparing for sizes? Is because in a allocated block, we don't need like the previous and the next pointer, because like there's no use because it's an allocated block. Like a free block is supposed to have previous block, previous pointer and next pointer, so as to show like that it is a part of a free list and to like point to the next free block or previous free block. But since an allocated block doesn't need it because it's allocated, so we'll just heat up the two pointers also. So in the worst case scenario, like the smallest block, this is 0 plus 8 plus 8, which is always like greater. So 16 at least and 8, that's fine. And then yeah, this is fine. So here let's say 5 bytes becomes 8. We get output from here. Let's say we don't get output from here. So let's say no ideal block was found. So this is where we come. So new block is equal to memsbrk align size. So here what's happening is that let's say when like the smallest free block should always be of at least like the smallest free block. What does the smallest free block look like? It looks like size value, previous pointer, next pointer, and then size value again. So the smallest free block, which has like no space, as you can see, no space at all. There is a like I should have somewhere over here the architecture of the like the design of the free block, but I guess this is fine. So in this case, then like the align size is like 8 bytes. So this will be like align size 8 plus 8 plus 8. This is like a 24, like this is a 24. But if we try to free this block, it should have at least 32 bytes. So that's what we will do over here. Here we will ask for an extra pointer size so as to write, oh, sorry, it's not outside. Yeah, calling them as BRK for new block because we didn't find the one with appropriate size and size in the free list. The two size trees are added because we want them even if it is a allocated block. And the pointer size is present because the block should be at least what is it 32, right? 32 bytes. Yeah, I guess this is fine. Accommodate the new previous pointer. Yeah, so Then we what do we do? Set the size value of the header as +1. Yeah, this is fine. And the footer new block, which is we move forward by so size, and then we. I know this will cause like internal fragmentation, but I guess this is fine. It's fine, not a big deal. So size t footer new block, size t cat new block plus size t. We move from the size t plus align size. I guess we will also move by pointer size too. We should just make it align to 16 bytes, right? That will be much easier. Okay. Now that I think about it, I think we should make it align to 16 bytes. But okay, let's just look at the working and yeah, if it's not correct, like if you come across a problem, then we will change it to like 16 bytes. So here we have like a macro which is aligned. This should be above. Yeah. So yeah. So this is alignment. And this is the macro, which is like aligns the size. Okay. Then 150. Yeah. So we ask for the footer new block is new block plus size t plus align size plus pointer size. That's yeah. Then footer new block is align size plus one. Well, it shouldn't be align size plus one. I think we need to make it. Okay. So get status. What changes do we have? So it's present. Yeah, yeah. Normal changes. Let's restore it. Okay. Let's make it align to 16. Yeah. So this will be aligned to like 16 bytes. The alignment from config.h. All blocks must have a specific minimum alignment, which is 16 bytes. Alignment requirement for config.h means. Is it allowed though? Are we allowed to do this? Let's take a look. So config.h. I don't think we are allowed to do that. Alignment requirement in bytes. If we change this, what will happen? No, I'm confused. Config.h, malloc configuration file. This is the default path where the driver will look for the this. Um, so okay, how about we take a look at like what is like the config.h, like what is the importance of it? So uh, no, okay, okay. Let's go with the hard part, which is like that's like for the one which we did. So like over here, so plus pointer size to the new block accumulates the pointer size, then pointer size is align size plus pointer size. Sorry. So here plus size, return the pointer new block plus size t size. Yeah, this is fine. Phew. Okay. So let's say we do find the block. Let's make like okay. The additional pointer size is to accommodate the new previous pointer for doubly linked or doubly linked list. Yeah. And the data size pointer is yeah. So now we are going to get to the part where we do find the appropriate block in the free list. So this was the part where we didn't find the appropriate block, which we were calling SPRK for memory. And now here is the place where we do find the appropriate block in the free list. So head size pointer is like size t by size t forward. Wait. Oh yeah, we return the address of the next pointer. Right. And then we get the size value. So head pointer, actual block size is dereferenced, and then footer size pointer is previous output plus pointer size, previous pointer plus pointer size again plus pointer size. Getting the pointer to footer, here we are thinking only of the pointer is we are here, hence only moving the pointer plus pointer size, not caring about the free space is present. Yeah, okay. Here we check if the space left is greater than or equal to 24. So this was the like minimum space. So the minimum space must be if it's that's the minimum space. The size difference, actual block size minus the line size. Yeah, let's change the value of minimum space. Yeah, so then we'll change some things for you. Minimum space should now be 32 because we are trying to like accumulate like two size values and two pointer values. So if size distance is greater than uh, minimum space, block space is equal to an actual block size. Right? So block looks like size plus pointer plus space plus size again. So the total space that can be utilized for process is space plus point size, space plus pointer size. Yeah, yeah. So the block space that can be utilized. So that's let me think about it. We are being recorded. Okay. Hello. Yeah, it's working. 14 minutes in, and okay, it's fine. Uh, I'm working on my whiteboard to make some visualization, so it will be like better. Always visualize stuff, Always write things down. It's like easier. Okay, so so the block space. Yeah. Okay. So let's say this is my block, just size, pointer, pointer, and size again. Should I show you guys what I'm doing or like what I'm working on? Okay, so okay. Wait. First, let me think about it. So this is size, this is pointer, pointer, size, the actual space, so the block space. Let's say I can get a free space. Yeah, so this is correct. As I said, like we don't, our allocated block doesn't don't like it doesn't need a previous in the next pointer. So hence we have like eaten up those two pointer spaces. So actual block size which we get from uh like dereferencing the thing. Yeah. So pointer size plus pointer size, and then we reduce in line align space from it. Line size, yeah, that's fine. So line size, we move here, and then we are left with block space. Yeah, that's correct. So that's fine. So split block is like previous output plus pointer size again, plus align size plus size. Yeah, that's correct. Okay, start a new, uh, start a new free block. So real block space is equal to real block space is equal to subtracting the space of two size deep values from one key pointer for the new block. Yeah. So here we should also reduce pointer size again. So header split block. Yeah, correct. And then we have footer split block plus size t plus pointer size, pointer size, header. Yeah, real block space. This is fine. Hmm. Yeah, okay. So split block pointer. Okay. So split block pointer is equal to pointer to pointer. We're getting the next, we're getting the pointer to the split block. Yeah. So we have, sorry, hold on. So split block pointer is equal to split block, the starting, the size, t size. That's perfect. And we are setting it to the free pointer. Yeah, here we have to like make a change. Okay. So here we have set. So now I realize we haven't done two things. So we made some changes to the split block, but we did not make changes to the size block, right? So over here we have like set, like we have the size pointer, footer size pointer to define the block. Size difference is greater than minimum space. So block space is equal to. So yeah, now that I realize we did not accumulate like not accumulate, but we did not make changes to the uh, the 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 utilized block. We have to change like the size values for it. We did not do that. We only changed the like size values for the header and footer. Should have done that. Not bad. So yeah, we'll do that. So real block space is equal to block space. Yeah, this is fine. This is fine too. Yeah. So now you have to make it so like so three pointer points to that, and then we yeah we have to also so here we are taking care of the next pointer. We are not taking care of the previous pointer. So split block pointer, split block. I should say next pointer is this, and split block next pointer becomes the new free pointer, and free pointer points to split. Yeah, this is fine. So here we do this. I think we should make a like completely different function for it. How many minutes in? 21 minutes in. Yeah. Okay. So yeah, let's get the value of the previous pointer of the block. That must be like change the value of the value. So three pointer. Let's call it like void pointer to pointer. First block is now like uh, let's cast void pointer to pointer inside it, and then we say like char pointer. We have three pointer with us, but three pointer. Yeah, yeah, that does not that does not do it right because we go over here. Let's see the three pointer. Okay, so it's possible. Let's change. Yeah. So first block three pointer plus. So this is a pointer to the next pointer, right? Let's move it by pointer size ahead. Yeah, and take it as like uh, first block previous pointer. First block previous pointer. Yeah, and now we dereference it. So like so first block previous pointer should now point to what is our new block, like our new previous block. Yeah, split block, right. So it should be what do we say? Pointer, pointer, char pointer, split block plus uh, plus pointer size ahead plus pointer size ahead again. I think this should do it. So what are we doing here? So we are casting like we are taking the pointer to the previous pointer of the first block. The previous pointer of the first block. We are changing its value to point to point to like the current split blocks pointer. Okay. So this should be dereferenced, right? This just split block plus pointer size plus pointer size. You just get the value that is present on it, right? I'm really bad at pointers. Damn. Also, my brain isn't working because I have like headache and like I'm not well. I have some fever also. So my brain isn't at like full capacity. But I guess even if it was at full capacity, like if it was like working normally, I still think that I won't be able to do it. But that's fine. Let me think. So split block plus okay, free pointer plus pointer size. We take the uh, we take the first block previous pointer and we say it's a pointer row pointer, and then we dereference it. So to change the value, and then we change the value to we have to change the value to the address of the like we have to change it to the address of interviews. I get it. So we have to cast got it. We have to cast it with void pointer and we have to still like do it. We have to still like dereference it. Yeah. It looks horrible, but I guess this is fine. This looks horrible. This looks so horrible. So I guess it's fine. This looks so horrible. Split block previous pointer. Should I say like split block previous pointer? Yeah, I should say I should make a like split block previous pointer. Yeah, yeah. So split block previous pointer is equal to void pointer to pointer, and then we cast it into char pointer, and then split block plus pointer size plus pointer size. Boom, boom. This is like, and then I just uh, do dt boom. Oh, sorry, dt boom. So the reference value of the split block previous pointer. Yeah. That was so bad. So here we are changing the value of the first block previous pointer. So the first block's previous pointer now points to the current block's like the split block's previous pointer, and the split block's next pointer should now point to like the new free pointer, and it will become the new free pointer itself. So now we have to do one more thing where we have to change the which we should have done it earlier. So did we do it though? So header size pointer. So this is the MSBRK, right? And this is MSBRK. This is fine. So we get a header size pointer over here. This is fine. Size it behind, and then action block size. We get the action block size format. If it's smaller, then we are just let's change here first, and then we'll go above. So adding pointer size because articulate block doesn't need extra piece pointer space. Okay, so we should make it so like the header size pointer. Yeah, yeah, yeah. We should we should add it by pointer size again. So pointer size plus pointer size. Yeah, adding pointer size because I'll end with pointer size plus pointer size because the algorithm block doesn't need the extra field pointer space. Adding one because it doesn't need the extra next free pointer, next pointer, and leave this pointer space. Adding 1 because this signifies that the block is allocated because all the sizes are supposed to be multiples of 8, thereby being even. So all sizes universe allocated block. Why did I do this? Because I think it will help during the coalescing stage. Yeah. Yeah. So this is done. So let's make it so like we change the values over here. Okay. Have we used shadow size pointer? So better. Now we still need the size of this, right? Yeah. Okay. That's fine. Good. Header size pointer. Hmm. Okay. So we haven't used that. Creation block size. We don't need this. Get a size pointer. Yeah, let's keep it. That's fine. So if we do find that pop uses the pop pointer, so let's change false first, which is like okay. So uh, previous output, right? So size t pointer, header size pointer again. Why not just use the previous one? Okay, so size t pointer, header of allocated, header of allocated is like size t pointer, char pointer, release output minus size t size. So yeah, and then we also get one for the footer. So uh, what was it? I forgot. What was it? Yeah. So footer allocated is equal to size t pointer, char pointer, release output plus. So we have next pointer, right? So pointer size plus pointer size again plus aligned aligned size. Yeah, perfect. Sorry. So cabinets. So free pointer. Yeah, perfect. So now we change the values. So dereferencing the since we have to change the header allocated is we should become like pointer size should become like align size. Align size should become align size plus pointer size plus one. Yeah, that's perfect. So like footer allocated becomes align size plus pointer size plus one. Yep. Oh, this should do it. I guess this is fine, but this is like terrible code. So we should. I think we should remove comments. Like this is fine, but I can understand pretty much all of the things. I think we should remove comments and like do some like changes to the function. Like this is too much. The function should not be this big. Okay. This is fine. So I guess this is it. We have made changes to the manner. Let's check again. Let's do some try test again. So sorry. No, it's like 34 minutes, 35 minutes. And this will be like the smallest video. Sorry, it's 8:20 currently. Okay, so let's say my let's say size comes in and size asks for 1 byte, right? When it's not going to happen because we looked at the trace files and they are usually like more than like they are 100 bytes at least. But let's say in the worst case scenario, the size is like 1 byte. Okay, so 1 byte comes in, align size makes it 8, and then free list outputs is like traverse free list. So 8 comes in. So we are asking for 8 bytes. So current is copy, and next pointer is previous block is equal to null. Next pointer of previous block is null, is equal to null. That's fine because the previous block's sorry, next pointer of previous block points to the previous block inside the free list compared to the current position. Next pointer of the previous block. So current is not equal to null. Next pointer of previous block. I don't understand the naming myself, and I did that. Okay, why did I do that? So next pointer previous block points to the previous block inside the free list. Next pointer previous block points to the previous block inside the free list. So the previous block, we should have named it like previous pointer of the next block, right? Previous pointer of the next block. It should be previous pointer of the next block. So this is what this means is like the previous block. So this should be like a previous pointer of the next block. Oh boy. Ah, next pointer of previous block. 7 times. My God. Okay, let's keep on reading and highlight this. Okay, so this is currently none. So what this basically means is like the previous block is none. It's previous. It's like in the previous commits, its name was previous block, and I was like, oh, this is cool. Next pointer of the thing, but okay, messed up. So previous pointer. So current is not equal to none. We will like traverse the previous until our current is not equal to none. So basically our uh, sorry. So basically our uh, free list comes to an end. So not technically our next block, but helps in seeing current. Yeah, yeah. So next pointer of the current block is like current itself. We cast it, and that's fine. Sorry. So size block, current char size, yeah, current minus size t size, yes, and then we cast into size t, actual size is size block, and then we ask it for. So we ask it for actual size. So let's say our actual, like the smallest block is 0. So 0 plus pointer size, which is like 16 bytes. So we can allocate that. So this is fine. So this becomes pointer size plus pointer size, which is 16. It's greater than or equal to requested size, which is 8. And then previous pointer of the next block, previous pointer of the next block, next pointer of the current block, getting the previous pointer of the next block. previous pointer of the next block. So we do have the previous pointer of the next block. Previous pointer of the next block. So next pointer, dereference that, we go over there, we dereference that, we get that, we put it into char, and then we move the pointer size ahead. Okay, and then the void point, we cast it into void pointer to pointer, and then yeah, previous pointer to the next block. That's correct. So if next pointer of the previous block is equal to none, that means the appropriate block that we found was the first block itself. So our free pointer should be like uh free pointer will be next pointer of the current block. Next pointer of the current block. Yeah, perfect. And previous pointer of the next block should pointing to null. That's correct. That's perfect. Else next pointer of the previous block should now be pointer next pointer of the current block. Yeah, next pointer of the previous block. Just this. Skipping the chosen block and making the next pointer of the previous block point to the next block itself. Yeah, that's perfect. Next pointer of the current block is not equal to null. I guess there are some naming changes, but I guess we'll fix it. Oh boy, I'm too tired. Let's end the video. 42 minutes in is fine. So, thanks for watching this video. I'm Aditya Charney, and I'm an engineer for fun. Bye.